Welcome to lesson 5. In the previous lesson we explained difference of two squares or dots, factorizing using difference of two squares. So if you can please write down this exercise and complete these 5 sums, and then we're going to do the answers. Okay, right. So let's start with number 1. So number 1 was x squared minus y squared. So you've got two terms. We can't do anything in terms of common factor factorization. That's what we're always looking out for first, because my highest common factor is 1. I've got two terms as the negative in the middle, and both terms are perfect squares. So when I do my answers, it's brackets and brackets, plus minus. The square root of x squared is equal to x, and the square root of y squared is equal to y. That's my answer. Number 2, I've got a to the power of 6 minus 100. So both of these are perfect squares. My highest common factor is 1, so I don't have to worry about common factor factorization. But I have to find the square root of 6, a to the power of 6. Before we do that, a plus and a minus. So let's just have a look at the square root of a to the power of 6. So the law that we're using over here, there's an invisible 2 there. It's a to the power of 6 divided by 2. So if you want to convert a surd into a normal exponent, you're going to say a to the power of 6 divided by 2. So my answer over here will be a to the power of 3, because a to the power of 3 multiplied by a to the power of 3 gives me a to the power of 6. And then the square root of 100 will give us 10. And that's basically my answer. I also have to watch over here to see if I can factorize further, which in this case I cannot. Number 3. So in this case over here, that's a perfect square, that's a perfect square, there's a negative in the middle, and there's two terms. So there's two terms, negative in the middle, both perfect squares. That means that I can use dots. So the square root of x minus y squared is going to give me x minus y. I forgot my plus and my minus over there. The square root of 36 is 6. So that's my answer. Number 4. Once again, first thing I need to look out for is the common factor. In this case there is. So my highest common factor here is 4. And then it's 16x squared divided by 4, which gives me 4x squared minus 4b squared divided by 4 gives me b squared. So now you'll notice that over there, what's in the brackets is difference of two squares. I can use dots. Why? There's two terms, there's a negative in the middle, and both terms are perfect squares. So my final answer in this case is I write down the 4 as is, and then in terms of replacing this big bracket over here, I'm going to do dots. So it's plus and minus. The square root of 4x squared is 4x. I'll show you guys now how I found that. And then the square root of b squared is b and b. So let's just have a look at the square root of 4x squared. The law that we can use over here is we can break up this over here. We can say that's equal to the square root of 4 multiplied by the square root of x squared. So the square root of 4 is equal to 2, and the square root of x squared is equal to x, and that's where I got my, in fact I made a mistake here. So that shouldn't be 4x, that should be 2x. I apologize for that. So that's a 2 over there, and that's a 2 over there. Well, doing an extra step is sometimes necessary. So the square root of 4x squared is 2x, and 2x over there, and the square root of b squared is b and b. Let's have a look at number 5. Number 5, we've got 144 b to the power of 4c minus c. Once again, you'll see over here that our highest common factor is c, and I'm left with 144 b to the power of 4 minus 1. So similarly, we'll see here, this is difference of squares, that we can use dots for this over here. Why? Because I've got two terms, negative in the middle, both terms are perfect squares. So I've got a plus and a minus over there. The square root of 144b to the power of 4, I can break it up and say, okay, what's the square root of 144? That's 12. What's the square root of b to the power of 4? Is b to the power of 2. You guys see that? So the square root of b to the power of 4 is the same as b to the power of 4 divided by 4 divided by 2 is equal to b to the power of 2. That's where I get the b to the power of 2 from. And the square root of 144 is equal to 12. And then I've got a 1 there and a 1. By the way, if you didn't know the square root of 144 is equal to 12, a good idea would be, so that's the answer for that one. I can't simplify any further, but I would strongly suggest that what you did was learn this table. So you take 1 squared is equal to 1. So that means the square root of 1 is equal to 1. Let's just go through these quickly. 2 squared is equal to 4. The square root of 4 is equal to 2. 3 squared is equal to 9. The square root of 9 is equal to 3. 4 squared is equal to 16. And so the square root of 16 is equal to 4. 5 squared is equal to 25. The square root of 25 is equal to 5. 6 squared equals 36. The square root of 36 is equal to 6. So first spend some time to just learn this over here, and on the next page we can go all the way up to 12. So if you take 7 squared is equal to 49. So therefore the square root of 49 is equal to 7. Then we've got 8 squared is equal to 64. The square root of 64 is equal to 8. 9 squared is equal to 81. The square root of 81 is equal to 9. We all know 10 squared is equal to 100. Square root of 100 is equal to 10. 11 squared is equal to 121. Square root of 121 is equal to 11. And finally we've got 12 squared is equal to 144. And the square root of 144 is equal to 12. Okay, so as an exercise, please learn that. And then in the next exercise, we're going to just do one more exercise on dots before we move over to the next type of factorization. Thank you for listening.